12, section 6.2, combinations in the binomial distribution, video 2. In the previous video, I posed the question, how many ways can you select a combination of 3 people out of 10 total people? And I kind of gave it away and said the answer was 120. But where did I get that from? And what's the formula for counting the number of combinations? Well, there's a formula for it, and it goes something like this. If there are n distinct objects, in this case 10 people, then the number of possible combinations of selecting x objects, in this case x would be 3, is denoted by ncx. The n and the x are subscripted. And here's the formula, where ncx equals n factorial over x factorial times n minus x factorial. Now realize we haven't talked about factorials. That was another thing from section 5.4 that was omitted. So we're going to look at it really quickly. The expression n with an exclamation mark is read as n factorial. And what it means is you do a multiplication problem. You start with that number, and then you multiply by the number 1 less than that, and then the number 2 less than that, and you go all the way down until you hit 3, 2, and 1. So basically it's a long multiplication problem. For example, if I said figure out 7 factorial, that just means you start with 7 and you multiply all the way down to 1. 7 times 6 times 5 times 4 times 3 times 2 times 1, which is equal to something. That's just a calculator problem. Now, depending upon your calculator, you may have a factorial button. But even if you don't, your calculator should be able to multiply. 7 factorial is 5,040. Oh, also, part of the definition of factorial is that 0 factorial is equal to 1. So let's go back and answer the question we left at the end of the previous video. To count the number of combinations of selecting 3 people out of 10, we have to set up the problem 10C3. And what the formula for combination says is you put the first number on top of the factorial, 10 factorial. You put the second number on the bottom with the factorial, so 7 factorial. Then, getting ahead of myself, the second number was 3. And then you put a third factorial, the second one on the bottom, for the difference in the 2 numbers. The difference in these 2 numbers is 7, so 7 factorial. Then, each of these means a different multiplication problem. 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It's a long multiplication problem. 3 factorial means 3 times 2 times 1, much shorter, times 7 factorial, which means 7 times 6 times 5 times 4 times 3 times 2 times 1. And now you just multiply both sides and divide. Let's see, the top side, the numerator ends up being 3,628,800, whereas the denominator is 30,240. And if you divide those, 3,628,800, and if you divide those, you get 120. That's what I said earlier. So that's how I got the 120. Well, that's not entirely true. I did use this formula, but if you think I actually multiplied these out and divided these numbers in my head, you must think I'm a lot smarter than I really am. There's a trick to getting to this answer without going through these large numbers. It does require you setting up all the multiplication problems and remembering something very handy. In a fraction, you can cancel matching parts of multiplication problems. Both sides of this fraction are just long multiplication problems, which means every single number is eligible to be canceled. And if you'll notice, there's a big chunk I can cancel in mass. This 7 all the way down to 1 cancels with that 7 all the way down to 1. So in my head, what I was actually thinking was this. But you could reduce this even further. You could do the top as 720 and the bottom as 6. But this 3 on the bottom will reduce with that 9 and leave behind a 3. This 2 on the bottom will reduce with the 8 on the top and leave behind a 4. So all that's left on the bottom is a 1, so I don't have to worry about it. All that's left on the top is 10 times 3 times 4, which is where I got the 120. So calculating the combination is actually pretty straightforward if you have this formula and you understand what a factorial means. Start with that number, multiply all the way down to 1. The only exception is 0 factorial, which by definition is equal to 1.